Felon, and this summer I was working on package manager security. So, oops, wrong window. A little bit about me. I'm a rising senior at UT Austin studying math computer science. And this summer I was a security engineering intern with the Firefox Operations Security team. And my project just kind of focused on how package dependencies can affect the security and integrity of a code base. So the motivation for this project was the fact that attacks on packages by way of compromising dependencies are becoming more and more common. So for example, the left pad incident where a maintainer unpublished a package and then someone else republished it in good faith, but it was possible that that could have been malicious. And then just some other instances, ESLint and event stream, where malicious code was published to a package by someone who either the maintainer's account was compromised, or they just added them on as a maintainer thinking that they were a good person trying to actually help out. And then in terms of Mozilla repositories and services have vulnerabilities, whether we know about them or not. So through my work this summer, I found Mozilla repositories that use packages with active vulnerabilities and or packages that are unmaintained. And this only accounts for the vulnerabilities that have been found. So it's possible, it's very likely that there are still vulnerabilities in Mozilla code that we don't even know about yet. So for the first few weeks of my internship, I looked at the status of different package managers and ecosystems, specifically NPM, Cargo, and PyPy, to see how vulnerable the top packages were to attack. Two things I looked at were the number of leaks that packages had, package maintainers and contributors had on Have I Been Pwned, which is a website which will tell you if your email accounts and passwords have been compromised in different data leaks from different companies. And then I also looked at the number of maintained packages. And here maintained, we just define that to be the package had a release within the past year. So this first graph shows the total number of Have I Been Pwned leaks for all of the maintainers and contributors for the top X packages and ecosystems. So you can see I looked at top 50, top 100, top 250, and top 500. And here they're separated by ecosystem. And you can see that even the low end total, there's thousands of leaks. And as you get to the higher end, this blue line here is NPM. They're up to over 15,000 leaks, which are basically 15,000 possible vectors of attack. This is not the best representation of the data because just, for example, NPM lists way more contributors and maintainers than say PyPy does. And so this next graph adjusts for that. So it's the number of leaks on Have I Been Pwned averaged out per person for the different contributors and maintainers of these packages. And you can see again that NPM here is up at the top with 7, 8, almost 9 Have I Been Pwned leaks per person. And so, oops. And then onto maintenance, you can see that this, this graph just shows a percentage of how many packages are maintained. And it's in general pretty good. You've got high 80s and even some 90s. But again, NPM is here at the bottom. Even in the top 50, only 80% of the packages are maintained, which means that 10 of the top 50 NPM packages are unmaintained. So they haven't had a release in a year, which means that there's possibly a vulnerability in there that's exploited. And if it is in there, it hasn't been fixed. So the takeaways from the initial research were that the design and culture of NPM's ecosystem leads to packages that have a lot of attack vectors, and the culture being micro packages, which means packages that do one small thing. At the bottom here, you can see this package called is odd or even, which tells you if a number is odd or even, and it has 7 dependencies. And 2 of those dependencies are packages that are already included. It's just a different version. So you can see that if this is how it works for this tiny package that just tells you how if a number is odd or even, just in general, the NPM ecosystem, including a package tends to include lots and lots of transitive dependencies. And so this means that when you're using NPM packages, you're introducing a large attack surface into your code that you may not be aware of and that you're definitely not in control of. So then the next part of my internship, I was working on Dependency Observatory. So Dependency Observatory is a tool that Mozilla makes that allows developers to see how secure a package is before adding it to their, as a dependency to their project. So on the right here, you can see a scoring page for a package, In this case, it's Lodash, and it'll just basically go through and look at the different properties of the package, like number of dependencies, contributors, the number of vulnerabilities, and then assign like a numeric score to that package, and that corresponds to a letter score. So using what I learned from my research, I was able to change the scoring algorithm that's used to rate the packages to more accurately reflect how secure those packages were. So for example, I weighed the number of vulnerabilities more than the number of maintainers because previously, or in the original scoring algorithm, you used to be able to cancel each other out with those two things, which doesn't really make sense because a vulnerability is like, for sure you can exploit that, versus having a lot of maintainers is saying, oh, maybe this maintainer has a leak, but it's not guaranteed. I also removed points per vulnerability, not just once, because originally it would just take off points once if there was a vulnerability, but not per vulnerability. So for example, there was a package that had 4 like high severity vulnerabilities and it still scored an A, which shouldn't happen. And then the next point was making packages that have a higher critical vulnerability, like make them unable to score an A, because that doesn't really make sense. And then removing points for a large number of maintainers. So originally the scoring algorithm had it so that one maintainer would take off points because it's just like a single point of failure. And if they get compromised, the entire package is compromised. But then as you add more maintainers, you get more points. And so I added, I think, a cap of about 20 maintainers, because once you're getting 20 or more maintainers, you're just adding like a larger and larger attack surface to your package. So here, these graphs show the distribution of the letter scores. On the left-hand side, we have the graph, the letter scores before the algorithm changes I implemented. So you can see that the vast majority of the packages are scoring A's, which isn't like super likely. It's probably not the case that the majority of NPM packages are like the greatest packages ever that are scoring A's. So after the algorithm changes, you can see that this is like a much more plausible picture. Like it's pretty believable that the majority of packages are pretty good, but not the best. There's a handful of packages that are the best and score an A, and then the rest of the packages are just like sort of okay. Some other contributions I made to the dependency observatory, adding some CLI commands to load advisories from the GitHub advisory database, which is just a database that GitHub runs of advisories about packages that have vulnerabilities. So you can add that directly in the project, import that directly into the project database now, and then adding a command to load the breach data from Have I Been Pwned for a specific package. So you can like type in the package name and it'll download all the information about the maintainers and contributors of that package and how many leaks they had on Have I Been Pwned and which websites they were. I added a feature that allows you to compare the dependency trees of 2 packages. So you could do this between 2 versions of the same package to see like how it changed between the different versions, or you could do it between 2 different packages. And it'll just show you like which packages are in tree A, which are in both, and which are in only tree B. I also added a statistics page on the Dependency Observatory website with the graphs that represent the distribution of package scores, which were the graphs from the last slide. There are graphs for both the letter distributions and then the numerical distributions, and then just a bunch of other smaller miscellaneous bugs. But yeah, I wanted to thank my mentor, Greg, my manager, Julian, the whole FoxSec team, the university team, especially for making this internship work so well after moving it remote, and then all of the interns, especially my trivia team, Internal Flame. So thank you.